everybody. I am Rohan Kumar from class 7th B of Kendra Vidyalaya, Vikaspuri. I have been recently working on a Atal ideation project which name is Duraless traffic software. In this project, we have a problem statement of about on and 4 lane intersection. We are giving green lights periodically, first to lane 1, then to lane 2, then lane 3, and then lane 4. But the problem is that we use this system. If we use this system, we tend to sometimes not give green light to actually the lane that needs green light, but the lane that doesn't has any traffic or has traffic but is very less compared to the lane that actually deserves his own red light. Basically, we tend to give green light to lane which doesn't has any traffic, therefore wasting time of the lane which has a good number of vehicles. We presented a possible solution of a possible solution will be that we can install one camera on each lane on a 4 lane intersection and then detect how many vehicles are present on each lane with help of machine learning. After that, we can calculate which lane to give green light based on which lane has the highest number of vehicles. And also, there are many places in India where on a 4 lane intersection, one lane is always having higher number of traffic than the other 3 lanes. So, to prevent a situation in which our system will always give green light to the lane to that lane which is having higher number of vehicles whole day, we have installed a safe switch to prevent a starving condition inside our code, which will not let the machine learning model to give green light to a single lane whole day. It will check if we are giving a single lane green light for more than 120 seconds, and if we are, then the safe switch will prevent the starving situation, will restart the model and will not let the model give green light to the lane which always has higher number of vehicles whole day for another 120 seconds. So other lanes also have are having chance of getting green light, so we don't create a starving situation for the other lanes that we are having on a 4 lane intersection. This way we will prevent a starving situation in which one lane is always having higher traffic whole day. If we talk about idea, where we got this idea of our time wasted on red lights and accident that happen on road almost daily in India. To prevent wastage of important time, we came up this idea which smartly decided which lane to give green light on a 4 lane intersection using machine learning, and also prevents a starving situation in which one lane is always having higher number of traffic than other 4 lanes. So other 3 lanes also get chance of getting their own green light. Sorry. Solution. So solution is simple. Using machine learning, detect how many vehicles are present on each lane, and then calculate which lane to give green light and which ones to give red light. If we talk about future plans, we will refine prototype by making machine learning model more efficient and clean, so it can also detect two-wheelers without helmet and note number plates, and also refining and making the process easier to migrate between intersections, because sometimes intersections are not of 4 lanes but sometimes 3 lanes. There are 3 lanes intersection in that one in rural areas and cities. We will make it easy to migrate between different intersections, so it is easy to install and deploy on rural and city areas. I will also make detecting process of which lane to give green light and which to give red light much more efficient, so we have very less chance of errors in the plan. If we talk about the practical use, so as you can see here in this window called TK, we are having 4 labels, as you can see here. The first one is lane 1, as you can see, and the second one is lane 2, and then lane 3 is here, and then lane 4. Every label with, like for example, lane 1, lane 2, every label in front has a box, as you can see, a rectangle type of box which is either red or green. The first box with that represents lane 1 has a green, so every box represent the respective lane. Like this box represent lane 1 because it is in front of lane 1 label, and this box represent lane 2, this box represent lane 3, this box represent lane 4. and the color represent the state of the red light, that it is it green or is it red. For example, in the specific state of the application right now, you can see one is lane 1 respective box is green. It is green because it has a higher number of vehicles, and inside the box is a number, like you can see lane 4 14, lane 3 22, lane 2 7, and lane 1 24. So that's why lane 1 has the green box, because it has the most higher number of vehicles. That is why our system has decided to give it green light, because it has higher number of vehicles. But after 120 seconds, if we talk, it will give green light to some in between of these lanes, to prevent a starving condition for the other 3 lanes. And after 120 seconds, it will get back to the lane first with 24 vehicles, and green give green light to lane 1. And as you can see, there are currently we are taking videos as input. As you can see, there are different type of different videos for representing each lane. The first video represents first lane, the second video represents second lane, the third video represents the third lane, the fourth video represents the fourth lane. We are currently taking input from video, but we can change only one line in our code to take input from the cameras we have installed on every single lane, and make it a continuous work to detect the how many vehicles are present, and then giving green light. We can easily migrate between videos and camera, but for currently we are taking videos, but we can easily in future make it into cameras, and we have tested that on our machine. About cameras, that we can easily migrate between videos and cameras. In future, we will also make the process clean and efficient, more efficient, so the system that is it is running on with machine learning doesn't get hot, because sometime it is inevitable to prevent a situation in which the computer is getting extra heated up, because the machine learning and our program is continuously taking data from 4 cameras, and then detecting and then deciding which lane to give green and red. So sometime it happens that our computer got heat because of the program. That's why we have installed some measures to prevent it, but in future we will also make it extra efficient, so this doesn't happens too often. And as you can see, we have labels and boxes in front of them, which represent every single lane. Like lane 4 currently has red light, lane 3 currently has red light, lane 2 has currently red light, and lane 1 also doesn't has red light but has green light. This means lane 1 is currently having green light, because as you can clearly see, there is more traffic on the lane 1 rather than any other lane. You can see the motorcycles and the vehicles, and even the people, the pedestrians are walking, so that is also a case in which it is detecting higher number of vehicles right here. And you can see it is detecting 7 and 22 and 14 right here. And as you can see, we are having videos of different videos to represent every single lane. Every video has its different length, and we can migrate between cameras and videos if we want, because in a real world situation we will be having to deploy it on a real intersection. There we will be installing cameras, so that's why it's gonna be not videos there, but camera inputs. And that's it for this video.